Hey everyone, I'm Partho and today I'm going to explain the naive Bayes theorem, a beautiful yet simple way to use probability for prediction. So, without any further ado, let's get into it. Before we get into the naive Bayes theorem directly, let's just check out one simple thing conditional probability. So, it's the probability of one event happening given that another event has already occurred. It's usually written as P of A given B. It's the foundation of Bayes' theorem. Basically, how we update what we believe when we get the new information. Let's take a quick example. A coin toss. What's the probability of getting tails in a coin toss? 0.5, right? But what if I tell you that you have to toss the coin again, given that the previous one was tails? What's the probability of getting tails again? So you calculate zero point 0.5 previously, now zero point 0.5 again, you multiply and you get 0.25. Boom, simple, right? However, if I increase the variables, the problem becomes more complex. Let's check out another example to see how it can get more complex. We have two blue marbles and five red marbles in a pack. What is the probability of getting a blue marble? Simple, right? 2 by 7. But what if I tell you that we already took out a red marble on our first try? What's the probability of getting a blue marble now? It's 2 by 6. Simple, yet not so simple. What if I increase the number of bags from 1 to 4? What if I increase the number of colors from 2 to 7? This makes the problem more complex, and then we require a name Bayes theorem to get the solution quite quickly. So, what exactly is name Bayes theorem? Name Bayes theorem formalizes that idea. It helps us calculate the probability of a hypothesis, say a class or an outcome, based on previous knowledge and new evidence. It's usually written as P of h given E equals P of E given h times P of h divided by P of E. Too much jargon, right? Okay. In simple words, new belief equals to the likelihood times the prior normalized by total evidence. Still a bit hazy? Okay, let's just go back to our previous example. Sorry, here's the formula. You can note it down. But let's go back to our uh, problem here again, the initial one. So, what is our hypothesis? That the next marble is going to be blue. And what was our evidence? A red marble was drawn first. Now let's do the quick math here. What's the probability of blue? It's 2 by 7. Probability of red is 5 by 7. Now what's the probability that the first marble is red given the next one is blue? Now 5 by 6. Because we already took out the red one. And what is the probability that the first marble is red if the next marble is red? That's going to be 4 by 6. I hope it's still clear till now. And so we finally plug all these values in our name bias formula and we get that the probability of getting the next marble blue, given that the first one was red, is 2 by 6. Clarifies our logic, makes this name bias theorem to be true, and still it holds the basic thing that which all solved before even knowing the formula. Cool. Now let's look at one more problem where it connects us to our daily life. The unpredictable Brisbane weather. Will it rain tomorrow? Imagine if you could just predict whether it will rain tomorrow and then flex your friends. But how do we know that? So for this problem, we have taken the data of 10 days, humidity, wind, and temperature as our classes, where each class has only two variables. So for humidity, it can be high or low, wind can be strong or weak, and temperature can be hot or mild. So based on this data itself, we can predict whether it will rain tomorrow. So we have been given that tomorrow's weather is going to be high humidity, weak wind, and mild temperature. Will it rain tomorrow? I just says let's put a bet. Can we? Uh, so let's say I think it won't rain tomorrow because it's weak wind, right? Let's just try. So what do we do first? We make a table for each class here. Let's just see how to calculate that. So let's take first humidity. So we want our outcome to be rain or not rain. So let's calculate the probabilities for that. So let's start with rain. So let's just see where all we have rain. So here is rain once, twice, thrice, fourth, and fifth. Okay. So it rains 5 times in the last 10 days. Now, in these 5 times, where all was the humidity high? So once here, second time here, third time here, and fourth time here. Just plug the value. So 4 out of 5 times when it rained, the humidity was high. And so it just leaves us that only once the humidity was low. So it's 1 by 5.2. Cool. Now let's see when all it didn't rain. So once, twice, thrice, fourth, and fifth. Okay. So now we have to check where all when it didn't rain, the humidity was high. So it was high only once on the second day. So we plug in these values, 1 out of 5 here, 4 out of 5 here, and we have the table. Boom. Simple, right? We do the same thing for wind and we do the same thing for temperature as well. With this, we have the foundation of naive Bayes theorem complete. And now we are ready to plug in these values in our formula to get our probability. But before that, we have been given our evidence that the humidity is going to be high, wind is going to be weak, and temperature is going to be mild. Let's just calculate the probability of that happening. So, what is that? We plug in all these values and we get that our probability of evidence is 0.15. But wait, do you recall what P of E is? And where have we seen it before? Well, we have seen it in this formula, the naive Bayes theorem. We have it in denominator. Now the thing that remains is the numerator. So let's just calculate that thing. So what is the first step? We find out what's the probability it's going to rain. So we calculate what's the probability of humidity is going to be high when it rains. So it's 0.18. Similarly, we do for all these things. Where did we get these values from? From these tables. Just put these things in a simple sheet. Similarly, do it for that when it's not going to rain. Then we multiply all these things to the probability. So, do you remember the likelihood times the prior? It's the same thing here. We have multiplied the likelihood multiplied by that it's going to rain. Similarly, that it's not going to rain because since we have to predict, we have either it's going to rain or not rain. We have to check which one's better. Now we finally apply the name Bayes theorem. We plug in all these values and we get that the probability is 42.7%. So little less than 50. And let's look whether it's not going to rain. Uh, the probability is just 32% that it's not going to rain. So, probability that it will rain given these parameters is more than the probability that it won't rain given the same parameters. So, it's going to rain. Sorry, my bad. Wrong logic or wrong bet. Sorry, not wrong logic. So, that's it. Just let's recap on what we did today. We started by understanding conditional probability, the idea that new evidence changes how likely something is. Then we use that idea to build Bayes' theorem, which mathematically updates our beliefs based on our prior knowledge and new data. We first saw it with a simple marble example and we applied then to predict the weather, using probabilities for humidity, wind, and temperature to decide whether it will rain. That's named Bayes' theorem. Simple yet smart prediction. So I hope you gained a lot of knowledge from this and I hope to see you soon. Thank you so much.